All right, we're recording, so if you don't want your image on the recording, you can turn off your camera if you wish. And start in. So while I'm getting set up, go. First, everybody knows we have a short week this weekend. Actually, we have a 4-day weekend coming up, so it's nice. Okay, so we are where? We are over here. Okay, so no school on Friday, no school on Monday. Okay. The nice thing, of course, is we don't have school on those days, but the bad news, I guess, is that means there's less time to quote unquote cram in the material. I have 2 fewer days to go over stuff. Now I did gain a day over here, but you know, I'm not complaining. I'm not advocating meeting on Friday nor Monday. They're holidays. It just means I have to kind of go a little bit faster for all the other stuff. Okay. All right. So that was about 3 weeks for our first test, 3 weeks for the second test. So Friday the 26th, we're aiming for the second test. Okay, so normally we have quizzes on the last day of the week, quote unquote. So this time it's Thursday, so I'll give you a quiz on Thursday. Okay, I sent out a video. I was not going to go over any of the exam in class. You saw the video. So you can look at the video and go off of the video for the answers and so forth. It was 10 points each, so 10 times 10 is 100. And the grading scale was 90, 80, 70, 60. You should have gotten an email back from me on your score and the breakdown from each question, right? So 10 points each, 10 times 10 is 100. Okay, and my grading scale again is 90, 80, 70, 60. 90 is an A, 80 is a B, 70 is a C, 60 is a D, less than 60 is failing. And if you're quote unquote close, that's where the minus and plus grades come in. So 90 is an A. If you're at 89, then I might give you an A minus, and 88 might be a B plus, and so forth. Okay, so that's where the plus and minus grades come in. It should not have been anything that was unusual or weird. Maybe some problems were a little bit harder. I do agree the exponential one, the f of x equals c, a to the x, was a little bit harder, but it was still doable. You know, just regular algebra for it. Okay, quick ground rules, and this should be true in every math class, I think. Whenever possible, give exact answer. Exact answer means leave radicals as radicals, leave ln as ln, leave e as e. Don't punch it in your calculator. Once you punch it in your calculator, it's an approximation. We always like exact answers whenever possible. Okay. Now, that's the style for all the exams. So what I often say is, if you like the style of this exam, you'll like all the other exams because they're going to be just like that. And if you didn't like this style of the exam, you're not going to like any of the others because they're all just like that. Okay, about 10 questions. Nevertheless, whether you liked it or hated it, you should have said there was nothing that was weird or unusual. Some of you asked in the chat during the test, and I don't remember this kind of problem. Well, look back, we did problems like that. Like the polynomial one, you know, f of x is equal to 3 zeros, and then f of 1 is 3 or something like that. You can plug in, there was a problem just like that. Okay, so there was nothing weird, nothing unusual, nothing out of the ordinary. And by the way, that's borne out by the fact that everybody got some of the questions. If there was no problem that everybody missed. Okay, so every single one of the 10 problems, somebody got 10 points on. Okay, so therefore somebody got it right. Okay, so it was not a weird question. It was not an unusual question. Okay, so that's as much as I want to say on the test. And that's pretty much all I want to say about it. Yeah, I do see something in the chat. I won't get to it yet. If you want to put stuff in the chat, go ahead. Or maybe Prasanna can get it from me if you don't mind. Okay, but we're aiming for the next test in 3 weeks. So we had 3 weeks for the first test, 3 weeks for the second test. Holiday on Friday, holiday on Monday. Great, but it just means I have to go a little bit faster on all the other stuff. Okay, so here we go. We're on to 2.2. And I alluded to it a little bit last time. So I was not going to do any more of 2.1. Okay. I finished it last week. Okay. Now I said at the time, well, don't look at it that carefully until after the test. Well, it's now after the test, so you can now go back and do 2.1. And I'll start 2.2. I know I just flew through 2.2 last time, but now we'll go more carefully on it and start building your next cheat sheet, right? Start building up for your next formula sheet and so on. Okay, so on page 83, okay, this new notation Okay, so yes, we are beginning calculus proper. Some of you told me, about a quarter of you said you have calculus background. Please try to pretend you don't have any calculus background. So if you have any shortcuts for derivatives, you don't get to use them. Okay, this notation, limit, LIM stands for limit, x arrow A means x approaches A. Limit as x approaches A of f of x equals L. That's how you say it. Okay, very roughly, very crudely, this says when x gets very close to A, but not exactly A, you're getting close to A, then the function values or the y values are close to L. Keep in mind f of x is like y, okay? F of x, y. Okay, when x approaches A, when x gets real close to A, y comes very close to L. Okay. Now, I showed you these pictures very quickly last time, but now let's analyze them. Page 84. Figure 2. I'm lifting up the book so I can't point it out to you, but see where it says figure 2? Limit as x approaches A of f of x equals L in all three cases. Okay, let's look at case A. Case A is probably our favorite, the one that we like the most. It's smooth. We're going to call that a continuous function. The graphs that we like are continuous. Okay, now in this case, it is true that right at x equals A, the function value is L, but that's not what this says. Okay. If it's out of focus, sorry, I got to put the book down. Okay. This says when x gets really, really close to A, coming from either the left side or the right side. Okay, so I'll raise it up. If I kind of come like this or like this, the y values are close to L, the limit. Yes, f of A is equal to L, but that's immaterial right now. When x is close to A, y is close to L. Let's look at B. Look at the difference between A and B. It's the same graph, only right at x equals A, they seem to punch a hole at L, and the dot comes down here. So f of A is not equal to L, but we're still going to say the limit as x approaches A of f of x is still L, because when x approaches A, when x gets really, really, really close to A, on both the left side and the right side, the y values are near L. Even though right smack dab at A, exactly at A, we jump down to over here. That's still okay. We're still going to say limit as x approaches A of f of x equals L. Okay, and finally, case 3, look at the third graph. Okay, so let's compare the first graph, A, B, and C. Now, B and C look exactly the same, except there's no dot for A. There's still a hole. So f of A is not even defined. It doesn't matter. We're still going to say limit as x approaches A of f of x equals L. Okay. Basically, we're saying we don't care what happens right at A. Right at A, it could be here. It could be somewhere else. It doesn't even have to be defined. Okay. When x is very, very close to A on both the left and the right side, the y value is very close to L. So in all three cases, we will say the limit as x approaches A of f of x equals L. Okay. Now look at example 1. Okay, I'm not going to go through the nitty-gritty details of the table here, but I'll refer to it quickly. Guess the value of the limit as x approaches 1 of x minus 1 over x squared minus 1. And we claim this limit exists, even though f of 1 does not exist. Okay, so you can tell you're not allowed to plug in 1, right? Because you can't divide by 0. Okay. But I am allowed to plug in numbers that are very close to 1. So look at what they did. They made a table of values, and they plugged them in, where x is approaching 1 from the left side, 0.5, 0.9, 0.99, 0.999, 0.9999. Okay. And here are the function values. All of these are defined. Now what's happening here? It's a table of values where x is approaching 1 coming from the right side, right? 1.5, 1.1, 1.01, 1.00, 1.0001. Okay, so in other words, that table is representing this picture that I've shown you a couple of times already. Way back over here on page 79, right? Remember this one? You fix the point P. The top 3 pictures, Q is getting close to P coming from the right side. And these bottom 3, Q is approaching P as we approach from the left side. And take a look. So 0.6, 0.5, 550, 500, 500, 25. 0.4, 0.47, 0.49, 0.499, 0.49999. So it looks like the limit approaches 0.5 or a half. Coming from both the left side and the right side, the y values are very close to a half, even though f of 1 does not exist, right? You're not allowed to plug in 1, but we don't care. We're saying when x approaches 1, that arrow means approaches 1. When x gets really, really close to 1, the y values are close to a half. So we're going to say the limit as x approaches 1 of the function is 0.5. Okay, so we're getting very, very close to 1. Okay. And another quick example here, top of 85. Estimate the value of that limit. Okay. And you're noticing something here. This happens to be an even function. Okay. If you plug in t or negative t, you get the same thing. So notice how they go plus or minus, whatever, right? It's going to be the same thing coming from the left and the right. Okay. Now, even though you're not allowed to plug in 0, take a look, right? You can't plug in 0. You'll be dividing by 0. Mathematical no-no. But this limit as t approaches 0, that does not mean you're plugging in 0. You're plugging in numbers that get really, really close to 0. So look at what they got. Plus or minus 1.0, 0.5, 0.1, 0.05, 0.01. Right? We're getting really, really close to 0. Those are all defined. Plug it in. Okay, 0.16, 0.16, 0.16, whatever. Okay? And then you notice that this number happens to be roughly 1/6 as a decimal. If you plug in 1/6, it's 0.16 repeating. So they're saying the limit as t approaches 0 of this mess is equal to 1/6. Okay. All right, so that's what we're up against. Okay. This one. Now, this is a pretty key one. I would say put this on your cheat sheet. Put this one on your formula sheet. We're going to need that quite a little bit later. Limit as x approaches 0 of sine x over x. This also happens to be an even function, which means you get the same thing if you plug in a positive or a negative value. So you did that. Now, you cannot plug in 0, right? But you can plug in stuff very close to 0. So plus or minus 1.0, 0.01, 0.005, 0.001. Okay. And what do you see? 0.99999, whatever. That's very close to 1. And by the way, unless we say otherwise, when you punch in your calculator, these are in radians, not in degree mode. These are radians. Okay. So we're going to say the limit as x approaches 0 of sine x over x is equal to 1. Okay. And here's a graph of the function. Okay. And by the way, if you try to graph this, if you have a graphing calculator, it won't show this. It doesn't do a good job at drawing dots or holes, but there is a hole there. So as we get really, really close to x equals 0 on both the left side and the right side, y values are very close to 1. Okay. As you can see there, extremely close to 1. So we're going to say the limit of the function is 1, even though right at 0, it's undefined. Okay. And of course, we can punch that in our calculator. Let me check to make sure. Okay. Right now I'm in degree mode, so you have to make sure you're in radians. Okay, so there I am in radians. Get back out. Okay, so how about sine of 0.0001 divided by 0.0001? Whoops, sorry. Look at that, 0.9999. It's 1, right? It's very close to 1. And if you plug in like 0.0001 divided by 0.001, you'll be more 9s. It gets closer and closer and closer to 1. Okay. So put this one on your cheat sheet. I think it's worth it. Limit as x approaches 0, sine x over x equals 1. We'll have some homework problems later, not today later, but further down the line where that will show up quite a bit. Okay, page 87, one-sided limits. What we've been doing is two-sided limits. That means we're approaching a number from both the left side and the right side. Okay. Well, you can decide to only approach from one side or the other. Okay, so here's something called the Heaviside function. H of t is 0 if t is less than 0, and 1 if t is greater than or equal to 0. This can be thought of as the turning on of a switch. Okay, in binary, you turn on a switch like within the computer. Okay, it's either zeros or ones. Okay, so it's a 0, then you turn the switch on, and now it's a 1. right? So 0 or 1. All right, so as this function approaches 0 from the left, as I come in this side, okay, the function approaches 0. But if I approach coming from the right side, well, we're up at 1. Okay, here's the notation. If you're approaching from the left, you put a little minus sign. Limit as t approaches 0. The minus sign, almost like an exponent, it's raised up there, it's a superscript, but the minus means coming from the left side. If they superscript with a plus, t approaches 0 plus, it means coming from the right side. Okay? So only coming from the left, only come from the right. And that leads to these notations, page 88. Okay, so one-sided limits. Okay, so see, limit x approaches a from the left. You write a, and then almost like an exponent, a minus sign. Okay, you're only approaching coming from the left side. Okay, and I want to emphasize that minus sign doesn't necessarily mean it's a negative. It might be negative, it might be positive. It's just coming from the left. Okay. And similarly, if you have a plus sign right over here, limit as x approaches a, and the superscript with a plus, you're only coming from the right side. Limit as x approaches a from the right of f of x is equal to L. Okay. So if they don't give you any symbol, then it's two-sided. Two-sided. If you see the minus sign, you're only coming from the left side, and I'm not sure how it works right now. If I'm doing my left, if you see my left or my right side because of the mirror image, but I'm trying to show you coming from the left. I don't know if you see left or right. Okay, but you get the idea. And then if there's a plus sign, it means you're coming only from the right side. I'm saying right. On your screen, it looks like I'm the left. It's really the right. Okay, so you're coming from the right side only. Okay, well, you can see it here if I show you this, I know. Okay, so only coming from the left, only coming from the right. Okay, and then we have this, number 3. Limit as x approaches a. That's two-sided. So when do you have a two-sided limit? Well, if and only if the limit coming from the left, see where it says a minus, and the limit coming from the right, see where it says a plus, and they're the same thing. Okay. Now, what if they're different? Then we would say the two-sided limit does not exist. Okay, so for the so-called Heaviside function, this one, the two-sided limit does not exist. Okay, I would say the limit as x approaches 0 from the left is 0. The limit as x approaches 0 coming from the right is 1. Therefore, the two-sided limit coming from both sides, two-sided limit does not exist. You have to have the same thing on both sides. Okay, our abbreviation, I think I said this before, our abbreviation for does not exist is DNE. We'll be writing that a lot. So you can just write DNE for does not exist for one-sided limit. Okay. Page 89. Infinite limits. Limit as x approaches 0 of 1 over x squared. Okay. Again, you're not allowed to plug in 0, but I am allowed to plug in stuff very close to 0. And again, this is an even function. Since it's an even function, they did plus or minus. It's the same thing if I plug in positive and negative, right? So here we go. Plus or minus. What are they doing? They're approaching 0 from both the left and the right side. So plus or minus 1, plus or minus 0.5, plus or minus 0.1, plus or minus 0.001. 1, 4, 25, 100, 10,000, 1 million. What's happening? The function's blowing up. It's getting bigger and bigger and bigger. Okay, this happens to be the graph. So the language we would say is the limit as x approaches 0 of 1 over x squared is equal to infinity, as you might think. Okay? It just gets bigger. I mean, look at the table. 1, 100, 10,000, a million. It just gets bigger and bigger and bigger. And you can tell from the graph also. Okay? So a limit can approach infinity. It can also approach negative infinity. Okay. All right. Here's another picture. Limit as x approaches a of f of x is infinity. Okay. Now this is two-sided, but you can also be one-sided. So maybe one side you go to infinity, the other side you go to negative infinity. That's allowed. Or maybe one side you go to negative infinity and the other side you go to 5. That's also allowed. And we'll see examples of that too. A lot of theory right now, page 90. Limit as x approaches a of f of x is negative infinity, right? So look for figure 13. As we get real close to x equals a, on both sides, both the left side and the right side, right? The y value is dropping toward negative infinity. Okay, so that leads us to a vertical asymptote. Okay, you've seen vertical asymptotes before. Okay, there's a formal definition of a vertical asymptote. I don't think you have to worry about it. So I would not advise you to put this on your formula sheet, on your next cheat sheet. I don't think you need it. But one of these has to be true, right? The limit as x approaches a of f of x is either infinity or negative infinity, or the limit from the left or the limit from the right is either infinity or negative infinity. Okay, so all of these would be considered vertical asymptotes, right? Go like that, or like that, or like that, or like that. Okay, vertical asymptotes. Okay. And here's a quick graph of the tangent function. Remember the tangent function, figure 16? So you have a whole bunch of vertical asymptotes, right? X equals what? Negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2, and so on. Okay, it's worth knowing that. Okay, also worth knowing for the natural log function. This is a biggie. I think if you are uncomfortable with that, put it in your formula sheet. Okay, ln looks like this. So limit as x approaches 0 coming from the right side of natural x is negative infinity. Okay. Notice it's one-sided. If they just put limit as x approaches 0 from the left, that does not exist. There's no graph over here. And likewise, if they just put limit as x approaches 0 and they don't give you anything, no minus or plus sign, right? That would mean two-sided, but there's no two-sided limit here because there's no graph on the left side. So that would also be a DNE, does not exist. But the limit as x approaches 0 from the right of the natural log function is negative infinity. Okay. All right, and what time is it? 9:35. I think we're finally ready to get started with some of these homework problems. All right, so 4 through 11 all, 15 to 18 all, and so on. So I'll try to do as many evens as I can, and we'll see how far we go. Okay, there's a lot of ground I have to cover. I'm not sure I'm even going to give you an in-class assignment today. I may just need to lecture the whole time. You know, what an outrage, right? Okay, but that's the way it goes. Okay, so 4. Again, unfortunately, yeah, we're not meeting on campus. If we were meeting on campus, I could project this and use the whiteboard. I can't do that now, so you just have to, you know, write it down for yourself as I say the answers, I suppose. Okay, so 4, use the given graph of f to state the value of each quantity if it exists. If it does not exist, explain why. Never mind about explain why. It doesn't exist because it doesn't exist. Okay, all right, so the graph goes like that. Let's see, there's a closed circle here, open circle here, and goes up like that. And if you can look carefully, there's a hole at 4, 4. See right there, 4, 4, there's an open circle. And there's a closed circle at 2, 3, and now the book is too heavy. I'm going to put it down. All right, so let me see what I can do. A, limit as x approaches 2 from the left of f of x. Okay, so we're approaching 2 from the left side. We're here. So we're here, 3. So the answer to 4A is 3. You can put down 3. There's no work for this one. Just put down 3. 4B, limit as x approaches 2 from the right. Okay, so we're getting close to 2 on the right side, and the y values are down here. So we're here 1. So the answer to B is 1. Sorry, I can't write it for you easily. And then what about C? It just says limit x approaches 2. Now for C, see how they don't give you the minus or the plus like A and B? Right? So A, the minus sign means you only come from the left. The plus sign means you only come from the right. For C, they don't give you the plus or minus. It's two-sided, coming from both directions. So what's the two-sided limit? Well, to get the two-sided limit, the answer to A and B have to be the same. Were the answers to A and B the same? No, they weren't. So C is DNE, does not exist. Okay? That's the idea behind a two-sided limit. Okay, f of 2. That's just like before. Right exactly at 2. Not a little bit to the left, not a little bit to the right. Exactly at 2. Is there a closed circle? Yes, there is. It's over here. So where's here? 3. So the answer to 4D is 3. E. Raise it up there. Limit as x approaches 4. I don't see the minus sign. I don't see the plus sign. Two-sided. So as I approach 4 from both the left and the right sides, do I approach any one number? Yes, I do. That number is 4, right? Coming from both the left and the right, okay, the limit is 4. So the answer to E is 4. However, for F, what is F of 4? So right smack dab at x equals 4. Not a little bit to the left, not a little bit to the right. Is there a closed circle at x equals 4? The answer is no. So that's a D and E. It does not exist. F of 4 does not exist. Or you could also say undefined, but it's not there. Okay, 6 is similar, and I'm really going to get a workout here because unfortunately the questions for 6 are down here, but the picture is over here. So I have to keep going back and forth there. Let's look quickly at how this graph works. So it curves up. There's an open circle at -3, comma, let's see, 1, 2, 3, 4, and then it comes back down to 0, comma, 1, closed circle, 0, comma, -1, open circle, and open circle at 2, 2. And then it does this weird squiggling up and down stuff on the left side as we approach 5, and then it looks kind of quote unquote normal after that. Okay, so the idea here, see this squiggling thing? It means when you approach x equals 5 coming from the left, you do not approach any one number. Okay, it seems to bounce up and down between what? Between 2 and 4. We do not approach any one number. Okay, so let's give it a shot. Okay, so again, I can't write it. A, limit x approaches -3 coming from the left. All right, we approach -3 from the left side. The y values are here. So where's here? 1, 2, 4. So the answer to A is 4. B, x approaches -3 from the right side. So I come from the right side, approach -3, also 4. And I know the way it works. They're probably going to ask for the two-sided limit. So what about the two-sided limit? Yeah, see? Two-sided limit. How do I know it's two-sided? There's no minus or plus up there. So the answer to C is, did you get the same value for A and B? Yes, we did. Right. So the answer is 4. Okay. The two-sided limit. Okay. Now, pretend on the left side you got 4, on the right side you got 3. Then the two-sided limit would not exist. You have to get the same thing. D, h of -3, 6D. So right at -3, exactly at -3, not a little bit to the left, not a little bit to the right. Is there a dot at x equals 3? No, there isn't. There's an open circle there. Okay, so the answer to D is does not exist. You can put D and E. Okay. You can put this right on your homework. I'm giving you the answers, folks, in case you didn't catch that. Okay, then same thing about 0. Let's see. Maybe I don't have to switch back and forth. Okay, 0 from the left, 0 from the right, two-sided, h of 0. Okay, I think I have that memorized. Okay, approach 0 from the left, right, two-sided, 0. Okay, approach 0 from the left. I'm here, 1. So E is 1. F, approach 0 coming from the right side. I'm down here. So where's here? -1. Okay, so I got a different value from the left as from the right. So what does that mean about two-sided? Two-sided limit does not exist. Okay, so G would be D and E, does not exist. Then letter H says H of 0. Right smack dab at 0, exactly at 0, is there a dot somewhere? Yes, there is. There's a closed circle at 0, 1. So the answer to H would be 1. All right, boy, this book gets heavy. Okay, then let's see. X approaches 2. Oh, it's both sides, right? See, look at I. They don't give you a minus or a plus sign. So two-sided, X equals 2. From both the left and the right, yes, the Y values are close to 2. If I'm coming this way or this way, the Y values are close to 2. So the answer to, where am I now? What was that? I? Letter I was 2. But how about J? And finally, I'm over here. Okay, J, what is H of 2? Right smack dab at 2. What's the Y coordinate? There is no Y coordinate. So J does not exist, D and E. And finally, K and L talk about 5. Okay. This one's easy, I think. X approaches 5 from the right side. So if I come from the right side, we get real close to here. So where's here? 1, 2, let's see, can't count. 3. So the answer to letter K is 3. And the idea behind L, X approaches 5 from the left. We do not approach any one number, okay? It just bounces up and down, you know. So are we approaching any one number? No, it seems to be bouncing back and forth between 2 and 4. So letter L is D and E also does not exist. Okay. All right, so that's that. Okay, what time is it? 3 minutes. Okay, 8. All right, so 8 goes like that. So it looks like we have a lot of vertical asymptotes. Okay, and going on from there. Okay. Yes, I see more stuff in the chat. I can't read it. Maybe Prasanna's got it for me. Okay, so function is A. 8. Limit as x approaches -3. And is that two-sided? Yes, it's two-sided. And how do we know? There's no plus or minus there, right? See how letter B and C have a minus and a plus? Okay, those are one-sided. So on both sides, on both the left and the right side of -3, do we approach the same thing? Yes, they both go to infinity. So the answer to 8A is infinity. B, x approaches 2 from the left, the minus sign. Again, the minus sign doesn't necessarily mean a negative number. It's just coming from the left. So that would be, if you talk about a real number, that'd be like 1.999999, right? So coming only from the left side, to what happens to the y values? They drop to negative infinity. So the answer to B is negative infinity. C, x approaches 2, and the plus symbol means coming from the right. It doesn't necessarily mean it's positive, although in this case it is positive. It means a number like 2.0001. Okay, so coming this side, the y value shoot up to positive infinity. So the answer to C is infinity. And then D, x approaches -1. Is that one or two-sided for D? Two-sided, right? There's no plus or minus. So on both sides of -1, yes, the function drops to negative infinity. So the answer to D is negative infinity. And finally, E, equations of the vertical asymptotes. Okay, you might recall from your algebra, the equation of a vertical line is x equals something. So you always have to say x equals blah, blah, blah. All right, so vertical asymptotes, x equals -3, x equals -1, and x equals 2. Put the book down because it's heavy. Okay, so the answer to E is x equals -3, x equals, what do we say, -1, and x equals 2. Okay, so that's what's happening. All right, continuing on to evens, 10, I guess. Okay, 10. A patient receives a 150 milligram injection of a drug every 4 hours. The graph shows the amount of the drug in the bloodstream after t hours. Find limit as t approaches 12 from the left of the function. Limit as t approaches 12 from the right of the function. Explain the significance of these one-sided limits. Okay, so here's what's happening. And this is a typical graph that you might see the amount of the medicine in the person's bloodstream, and you give them a dose every 4 hours, I guess. Right, so you give a dose, and then as time goes by, the body metabolizes the medicine, right? And then it goes down. And then maybe after a certain amount of time, the doctors or nurses say, okay, we got to give them some more of the medicine. And then it goes back up, and then the body metabolizes it and it goes down, and so on. Okay. So the one-sided limit. So limit as t approaches 12 from the left is 150. And then the limit as t approaches 12 from the right is 300. That's all. Significance. So just before we give the patient the dose at the 12-hour mark, okay, they have 150 milligrams of this medicine in the bloodstream. Okay, and then immediately after giving them 150 milligram dose, then obviously they jump up to 300 milligrams. Okay, and then of course the body starts metabolizing it after that. Okay, so I'd say just before the next dose, right at the 12-hour mark, the patient has 150 milligrams of the medicine. And then right after we inject them with the medicine, now they're up to 300. Okay, so that is that. All right, so let's see, where are we now? I've given you all of those up to 10, I guess. So I'm done with 4 through 11. 15 through 18, what's that about? Yeah, make up a graph. That's obviously a lot harder. Make a graph with the following characteristics. Okay, so how do you do that? Let's look at 16. Sketch the graph of a function that has all of these following characteristics. So I'm going to make myself a grid. We're going to make heads or tails as to what's going on, and I'll show you what I've got as time passes. Whoops, made a little mistake there. Okay, I've got the answers to 15 and 17 already, but I mean, I'll project it in case you want to see it later. It's 15 and 17. Okay, so what's 18, 16 rather? Let's get these out of the way. These are not calculus. Look at those bottom two. F of 0 equals -1. F of 3 equals 1. Those are just dots, right? So it's 0, -1, 3, 1. Okay, so that should be easy. Okay, F of 0 equals -1. 0, -1. That's a dot. F of 3 equals 1. 1, 2, 3, 1. You already knew how to do that in pre-calc. You probably even knew how to do that in algebra, right? So F of 0 is -1. F of 3 equals 1. Now, limit as x approaches 0, two-sided, of f of x equals 1. So when I approach 0 from both the left and the right sides, the y values are up here. So it has to be an open circle. So maybe something like this. So how do you know if it goes up or down? You don't. As long as it comes in like this and like this. You must not have a closed circle. Remember, these are all functions. Function has to pass the vertical line test. Okay. So there it is. The two-sided limit as x approaches 0 of the function is 1. Now, we're doing something about 3. When x approaches 3 coming from the left side, we're down at -2. -2. If we approach on the left side, we come down to here. So maybe like that. When x approaches 3, like 2.999, coming from the left side, the y values are down at -2. How about if I approach 3 plus means coming from the right side, the function values are up at 2. Now that's up here. So there's an example. And actually, I have it going up. It can go down. It can even go straight. But the main thing is it has to come in and get very close to the point 3, comma 2. So there's an example of the graph for 16. Okay, so quick double check. F of 0 is -1, dot at 0, -1. F of 3 equals 1, 3, comma 1. Remember, that's just an ordered pair. 0, -1, 3, comma 1. Two-sided limit of the function as x approaches 0 is 1. So when I get real close to 0 on both the left and the right side, I'm close to 1. But it's not a closed circle there. And then over here, right, if we come close to 3 from the left, coming from the left side, we're down at -2. We get real close to 3 from the right side, we're up at 2. Okay. So that's the way that one works. Okay, then let's see. 18 has all this stuff. Okay, so how about I'll show you 18. 18, and the numbers are all still not that big. 1, 2, 3, 4. All right, so they give you all this stuff. Now, my suggestion, I would advise you always get the dots first. Okay, the easiest things are these last two. That's not even calculus, right? I mean, these f of 0 equals 2, f of 4 equals 1. You already knew that in pre-calc. You already knew that probably in algebra, right? Those are just two dots. Okay, 0, 2, 4, 1. Okay, 0, 2, 4, 1, right? That doesn't change. Limit as x approaches 0 from the left of the function is 2. So when I get close to 0 coming from the left side, the y values are close to 2. And the function value right at 0 happens to be 2 also. Now, I had it coming this way. It could go like this. It can go straight. You can even have some fun and have it bounce up and down until it finally comes here, as long as it passes the vertical line test. Okay. Limit as x approaches 0 from the right of the function is 0. So when I get close to 0 from the right side, I get close to the origin. Okay, so maybe like that. How do I know it goes that way? I don't. It could go down. It can even go level. But that's an example of something that works. Okay, then let's see, where else are we? Okay, stuff happening at 4. 4 from the left, 3. Approach 4 from the left, 3. Okay. Maybe like that. Approach 4 from the right, 0. Approach 4 from the right, 0. Okay. And it already touches here. So you just, you can have it go down, you can have it go up. Your choice pretty much in that particular case. Okay. All right, so that's up to problem 18. We only have a few minutes left, so I think I was going to stop there. Okay, so how far have we gotten? Okay, so you should be able to do up to 18. So tomorrow I'll do 19 and on. Okay, and let me go ahead and check the chat right now. And hopefully, Prasanna, you got it all. Okay, and let's see. Are we allowed to have a cheat sheet in every exam? Yes, one formula sheet. Same as before, 8.5 by 11, double-sided. And by the way, when it comes time for the final exam, just keep them all. Don't make a brand new one. Don't reinvent the wheel. You're going to be allowed all the cheat sheets. So take the cheat sheet from the first test, second test, third test, fourth test, fifth test for the final exam. Okay. Let's see. Okay, plus minus minutes, okay. X approaches, got that. All right, I think got that. Okay, is it supposed to be 4-1? Let's see. 18, F of 4. 18, 4-1. You're right. It says 4-1. What did I put? I put 4-0. Okay, so fooey on me. All right, so I got to change this. So the dot should be here. My bad. And this should now be an open circle. I can make it look like that. Yeah, then it looks like I didn't make a mistake. Okay, so you're right. 4-1. Which goes to show you, don't always take everything I say as correct. I'm wrong a lot of the times, so I can get called out for sure. Let's see. Yes, you get to drop one exam, which could be part of the final exam, so that's still true. I think that's still that. Okay, so I think I've caught up with the chat. If I missed it, you can ask again tomorrow, but we're just about out of time. We won't do an in-class today, so that's pretty much about it. Okay, I think I've caught up. If not, send me an email, come to office hours, or talk to Prasanna, or ask again tomorrow. All right? Okay, that'll do it for today, folks. All right, so everybody have a good day, and we'll see you all tomorrow. Okay, bye, everybody.
Thank you.
Thank you.